Shalom, shalom. Hello, everyone. How are you? We are happy to have Boris Liberman here. It is a great pleasure that we welcome you to this special interview session with Dr. Boris Liberman. As one of the most recognized innovators in this field, Dr. Liberman's contributions have been instrumental in shaping the way we approach desalination and water sustainability today. So, on this International Water Week, we have the privilege of delving into his visionary insights and groundbreaking work. Please let me in extending a warm welcome to Dr. Boris Liberman as we embark on this enlightening conversation. Hello, Boris. How are you? So nice to have you here.
Thank you for inviting me. Thank you. I am okay. Excited to be here.
Thank you for being here. I hope we will have a good conversation. And let me please, maybe for those that you do not know your professional story, to introduce you through a short bio to all attendees. So Dr. Boris Liberman is a prominent figure in the field of desalination with over 40 years of experience. He currently serves as the CTO and Vice President for Membrane Technology at IDS Technologies. Boris holds a PhD from the Institute of Scientific Research in Water Supply, Moscow, and a BA and MS from the Civil Engineering Institute, Rostov-on-Don, also from the Soviet Union. Dr. Liberman's contributions to the desalination industry are marked by his innovative approach to solving technical challenges and his commitment to sustainability. Throughout his career, Dr. Liberman has been instrumental in developing several key innovations in desalination. These include the pressure center concept, direct osmosis cleaning, and the use of 16-inch membranes in a vertical configuration. He's also responsible for the ID Pro Green and PFRO technologies. His work has led to the design, construction, and commissioning of various membrane desalination plants, some of which are among the largest in the world. His leadership in the development of the Ashkelon plant, the first mega large-scale facility worldwide, and won the GWI Desalination Plant of the Year award in 2006, highlights his significant contributions to the field. He holds numerous patents in reverse osmosis desalination and osmotic power generation, and has been recognized as one of the top 25 industry leaders by Water and Wastewater International in 2015. His leadership at IDE Technologies and his numerous patents and publications have solidified his reputation as a leading expert in the field of desalination. So today's interview promises to offer us a unique opportunity to gain valuable insights from a true thought leader in the water industry. So without further ado, let us begin with this interview with Dr. Liberman and delve into the wealth of knowledge and expertise he brings to the table. So, Boris, this summary mainly reflects your outstanding career in Israel, right? But we know that you came to Israel, made Aliyah in 1990 with your beautiful wife, Anna. At this time, you were already a very experienced engineer. Please, I will ask you to tell us a little bit about Boris before Israel, please.
Thank you for a very nice introduction. Thank you very much. You know, I would like to start with my wife, Anna. Indeed, she worked here in Bank Tvachot 30 years, and he was a credit officer, and all whatever I made is my credit to Anna, because I don't do nothing at home at all. So thank you, Anna. And I would like to show you my family. All those people also made the Aliyah together with me. And as you asked, Miriam, I also brought the picture of wedding. You asked me, and I bring it. So this is our picture for wedding. And on the left side, you can see my son, Igal, and my grandchildren, Michal and Max. So from this point, I can explain that the Aliyah from Russia was very easy and simple. You have to give your home for free. You have to give your car for free. You have to forget your career in the Projection Institute where I worked 20 years. You have to forget your work in university where you teach 10 years. You pick up $200 US and you are clear to go to the Israel.
Wow. So just a piece of cake, huh? No money, no house. You are leaving a brilliant career behind to start from scratch. So I'm already want to ask you, how did you start your professional life in Israel?
In Israel, it was even easier because you have to forget your Russian language. You have to forget your Yiddish, what you talked at home. You have to forget your German, you studied in the school and university. You have to start to study two new languages, Hebrew and English. But I indeed was glad to get stipendia from the government, 2 years stipendia that allow me to work with Mikorot. So in Mikorot, I started a seawater pilot in Ashdod. A pilot bring to good operation. People in the country already know that seawater is possible in Israel. And after I finished the operation, I got a letter that I'm fired due to lack of payment. And the career in Mikorod was finished by this. Toby Levy, CEO of ID at this time, take decision to start membrane technology in ID, which was absolutely thermal desalination, MVC, MED. And we started to work and make the first projects.
Which was the first project with the membrane technology, right?
With membrane technology, the first project was...
Boris, sorry, I will ask you to move the slides.
Yeah, the first project in Israel was Ashdod refinery, 5,000 cubic meter a day. So the Ashdod plant was the first one. The very tight budget. In the end of the project, there are no money for degasifier, and degasifier can cost something about $50,000, no money for it. So I look on the cooling tower, Yerushalmi, but there are on the houses, and bought one of them. It was working very well. So the first innovation, if you like, it is using of the cooling tower instead of degasifier, but it worked 25 years very perfectly. And Yerushalmi started to solve his cooling tower as a degasifier. So all side was very excited.
Great story and a great start. You never were afraid of challenges. So it was your first experience more or less in Israel. And then what the next plant I see? Larnaca on the slide.
It was several between this and Larnaca. It was Brom, it was a lot, 8,000 cubic meter a day, seawater. But Larnaca was indeed very important project because the competition was tight, and ID was company with no name in RO desalination. So I did three things in Larnaca. First of all, to make some gap to reach this project, you have to make some gap. And first was the division of the permeate. The permeate from the front side of the pressure vessel and rear side of the pressure vessel is completely different. The permeate that is going out from the permeate outlet near the feet is very good. And the permeate that is going out from the brine side is high TDS. So the division that I made allow us to diminish the size of the second pass from 100% to 25%, save significant money on the capex and on the energy. And
what were the requirements for the water quality?
The requirement was 1 ppm of boron. This was the first time that governmental company request the boron removal. So the second pass was practically for boron removal. But also what we put to save the capex and the energy, 8 membrane in pressure vessel. And this indeed diminished the power consumption. And the last one, the third one, it was the post-treatment, because all the project at this time was lime and carbon dioxide pretreatment. In Cyprus, there are no local production of lime, no local production of carbon dioxide. You have to bring both of them. They're very expensive, but there was a limestone and sulfuric acid. So I take decision to make the post-treatment process from the limestone and sulfuric acid. Looks simple, but it is not. Because you have to make a limestone dissolution inside of a concrete reactor. You don't know what you will dissolute, reactor or limestone. This was the first challenge. And the second challenge was that limestone with sulfuric acid can be covered by calcium sulfate instead of dissolving calcium carbonate. You can close it with calcium sulfate and dissolve your reactor. But I solved this problem, and the project is working, I think right now, something about 30, maybe 25 years.
A little less maybe, but
maybe 20, 22 years. So this was the issue about the Larnaca.
I want to tell you something about Larnaca.
Yeah.
Okay.
Yeah.
So I was selling membranes and with Dow, and you asked for a quotation to work with 8 membranes in a pressure vessel, and then I got a letter from Dow and sent to you, and in the letter was written, don't even try to work with 8 membranes because it's going to be a big disaster. Okay, and as you said, you keep working, IDE and other companies working with 8 membranes in a single pressure vessel for almost 30 years. Although still people are asking us if it is going to work, but this is the moment to say, yes, it worked. Okay. So
yeah, I have to tell you that also my very good friend Mark Wilf also supported me in going to 8 membranes.
Yeah,
and he is great person, and I have to tell that I have a pleasure to be his friend for a long time and learn from him, and we work together. So the 8 membranes, the part of the credit I should give to Mark Wilf.
Definitely.
So And next interesting project was Ashkelon.
The first one in Israel, the first large-scale plant as the first one of the national desalination plan in Israel.
Yeah, absolutely. So the competition, as usually, is tough. If you don't bring low water cost, you are not able to reach the project, and between the competitors was very serious companies. So what I did at this time, I suggested the pressure center, where instead of 32 high pressure pump with Spelton turbines and this motor with MCC, we put three. We put three high pressure pump in operation, one standby, arrange all membrane in one block, what includes 16 trains, and put energy recovery in form of DVIR. I have to tell you, at this time of the tender, the ERI energy recovery not exist at this time. It was in test. But a great person, Bill Andrews, published a paper. And in the paper, he described that he made energy recovery system with 98% efficiency. During a tender, I take a flight to Bill Andrews. I look all these records and look on the flows and pressure and whatever. It was two small pipes of 6-inch staying beyond the smaller roll train with the link valve, but it works. It provides efficiency. So there was no reason that it will not work in big size. So I explained to Bill Andrews that I'm going to pick up his innovation in the Ashkelon project and build a pressure center from it. He told me, "You are crazy." But I have to tell you, Bill Andrews is a great person, absolutely great. He made his job so well. He worked on this commissioning of this energy recovery and take participation in the design of it. And I have to tell you, it is very, very high level person that help us to make this pressure center. In addition to the pressure center in this project, I use the Cascada, a boron removal system. You can see here in the Larnaca, we put the second pass on the rear products, but the recovery was 92%, because you cannot in the boron removal system have high recovery and high pH. It is not possible. Magnesium hydroxide scaling and calcium carbonate scaling will plug your membrane absolutely. So it is not possible to have two conditions in one train.
Just to remind, what was the boron requirement here? 0.3
ppm. It is never before. And before, all the technology mainly was built on the ion exchanger, expensive. The difference is 6 cents on cubic meter. You will lose your project on it. So I submitted the first patent in Israel on the Cascada, where we make 3 stages. First stage was high pH, low recovery. The next stage was high recovery, low pH. We put acid. And the third stage was high recovery and high pH, but was not calcium and magnesium, because both of them going out in the second stage. So the recovery was 98.4%, and we made this project what is working till those days.
I see, and I also see the very nice illustration that you are showing here, that your process is fighting with the boron, magnesium, and calcium. And no doubt it was really Ashkelon and still is an emblematic project. And you must be very proud that is working since 2005. But as Bill Andrews said, I don't want to repeat it, that I will say that you were very brave here, starting with so many technological innovations. This is true? You were just crazy and brave?
No, I don't think so. I made 14 mathematical models what are calculating all parameters, the chemistry, the hydraulics, the scaling condition, the pumps, interaction pump with membrane. The first time when in one program, I had the program of Rosa at this time, together with the program of the pump, together with the program of this booster pumps, chemistry, all things together. And I have to tell you that we have a model, math model of each piece of the pipes, all of them who are above 2 inch has a mathematical model. So there was no brave at all. And I can tell you about also something related to Carlsbad. During the tender of Carlsbad, it was very tiny place, and Poseidon looks to put huge capacity on this tiny place, and it was no technology which can come inside of this tiny place. So Nikolai Vauchkov, the third great person in my life, look on the pressure center and come to us, and he studied all 14 models. He come to every place in the plant. He talked to every operators to leave a light in the plant, in the control room, to understand if it is indeed working well. So it was checked by Nikolai in all possible ways before Nikolai give us the green light to precipitate in this tender. So the Carlsbad plant is actually a copy of Ashkelon. We only replace the Dvir by ERI, which is already was on the market at this time, and it was local production in California. So this is practically one thing. It is the same front and rear product, the same Cascada boron removal, the same practically post-treatment. Only we change the sulfuric acid by CO2 in this.
And the energy recovery.
And energy recovery, absolutely right.
So amazing, and really this it was the Carlsbad started in 2015, and already in 2016, I hope I'm okay with the dates, the Sorek tender was published. So you did some innovations for Ashkelon. You copied a little bit from this for Carlsbad, and then you could continue copying and paste for the next project for Sorek.
You know, with Sorek it is different story, because you cannot take tender with the same technology 2 times. You have to improve it every time. Other way, you will not making money and not reach a project. So you have to make better and better for each project. But at the time of the Sorek tender, in the fashion of the raw membrane comes 16 inch. Every membrane manufacturer made 16-inch membrane. It was, you know, very, very high level interest in the world, 16-inch membrane. So I look on the 16-inch membrane in the installation and arrangement, and I understand that in the horizontal position it cannot work. Installation is complicated. Air evacuation is complicated. Pipelines are very, many elbows, teeth, and so on. It is expensive. So what I did, I turned the pump in vertical position. And what has happened? Happened the following. It's very easy installation because you take all the membrane like sausages one after the other inside of the pressure vessel, simple and faster than 8-inch. Air evacuation is very simple. All air is going out without problem. The pipelines are simple and straight because you have one feed pipeline, piece direct line, one brine line, and two permeate if you like to have front and rear, and this is all. So the amount of the pipes and elbows are diminished drastically. The cost is diminished. The size, the footprint was 2 times less than even pressure center. It is very, very compact. It is very easy to maintain it because you have a flat level. What you can access all the pressure vessel easy on the level of your,
Your floor.
test. Yeah. And when you are going around, you are not exposed to any blast from the pressure vessel because it is not like a Katyusha staying in front of you. So it is very safe for maintenance, safe for operation, easy operation. And I hope the present operators will sometimes make some presentation and explain how it is working.
Yeah, I can tell you that someone told me that the operation is very easy, and it was really a great idea, and they are enjoying having only 25% of the pressure vessels and membranes for maintenance, and in a very, very easy way. So what I see here at Sorek is that you actually took from your first innovation 8 membrane elements, post-treatment with calcium carbonate. You took also here the pressure center, right? So in a way, your innovations were so strong that you could keep using it from plant to plant, and then you always had to find a new innovation because the other ones were known to everyone, and you have to bring this different gap to have the difference in the water price, right? To reach it, to reach to win the project.
Yeah, I would like, first of all, to give a credit of all the people who are working on the design and commissioning of this Sorek A, because I personally don't take a part in the commissioning and design of all things. So it is great idea team who are worked on this project. And this is a credit of those people.
And also it's so emblematic, the project, that when I met people abroad, people say, you're from Israel. I was at the Sorek plant. I even took a picture. I have a picture of the Sorek plant. And this is really very, very important. And really, we all know the importance of the seawater desalination. But you are a visionary, and with one eye you were looking at the innovation for seawater, and with the other eye you were looking for what is going at the market, right? And,
Yeah, you are right.
And you understood at any point that the market needs to focus on additional water sources in addition to seawater, right?
Yeah, you are absolutely right. And the next thing what I would like to little bit explain is the pulse flow role. In this point, I would like to give a credit to Magan Mikhail and Nadav and Barak and all people who are helped me in developing of this project in Magan Mikhail. Indeed, thank you. It is great people and great place to make development. But together with this, it was other people who are helping in this, if you like, in some way. It is Professor Efrati and Rick Stover. Those people are the first who understand that for the brackish water, industrial water, the life requests high recovery. And to reach high recovery, you have to make your cycle of desalination shorter than induction time. This was a great understanding what come from those people. They was the first who understand that high recovery means short cycle, so shorter than induction time. Maybe in a few words I will explain it. Because
explain it, of course.
You know, when you have some feed stream and you bring to squeeze it, you reach a level of supersaturation, and you continue to squeeze it, you are in supersaturation and very high supersaturation, but no scaling take place. Because you start induction time, the calcium and magnesium ion have to find them together to build a protocrystal. And if you are able to remove your concentrated solution out of the pressure vessel before the induction time finished and you build your protocrystal, you can reach extremely high recovery. And this is great understanding of those two peoples. In addition, those two peoples opened the market. It was huge job to explain to the market that they may request high recovery. It is easy to come to the market when the client asks you, okay, can you give me 95% recovery? But to bring the market to this position was a great job, very important. And Rick Stover, together with Professor Efrati, make this job. They open the market. So the pulse flow come later. It is used the same approach of the induction time. It is even shorter because what we are doing in the pulse flow, we are within 1 minute squeezing the feed stream in such conditions that you are several times above saturation point. But you don't keep this saturated solution in the membrane. You threw them out.
So you work at like in a dead end mode, right?
Yeah.
You close
brine valve.
The brine valve for a certain time, and then you suddenly open it. This is the pull.
Absolutely. So what we are doing, we are taking the stream, we are keeping it about 1 minute. Sometimes it can be up to 3 minutes, depends on the salinity, even shorter, 20 seconds. And later we are flushing the brine within 2 seconds. So we are flushing not with the amount of the water. We are flushing it with energy, what there are in this water. So if you are pushing it with very high velocity, you are clean up all this fouling what you have in the membrane. So what you know, in this, we are working in wastewater, in municipal wastewater, and we don't need no chlorination, no chloramine, nothing. Because there are no fouling and no biofouling. The understanding that fouling is related to SDI 5, not overcome the SDI 5, is forgotten. SDI 5 is not limit anymore. You can make water from SDI 6, even more. You know, in some projects, we get non-treated municipal wastewater without pretreatment 6 hours. And after this, the system cleans itself without any problem.
So this is amazing. And tell me about any, it works with the super saturation in calcium, sulfates, silica as well?
Calcium sulfate and calcium carbonate, can be in any level. It doesn't matter. We can reach any level. With silica, I would not say this silica is a simple issue. With silica in Cherokee metropolitan district, we are reaching almost 300 ppm, but silica is not easy story because it is have very short induction time. Even if we are working 2 minutes in the dead end, so we close the brine outlet, 100% is going to the permeate. Recovery 100% for 2 minutes. Later you open the brine for 2 seconds, flush out the all concentrated solution, but silica is serious story. I would
It's
right
a challenge,
now keep it at the level of 300, and maybe later we will make something better, but right now it is 300 ppm. We can work with it.
So this technology actually has been certified by different entities in the US, and also see that you wrote here at the semiconductor plants. So actually it is ready for the big boom of wastewater reuse, potable reuse. It is already a proven technology. So actually, I see that your innovations, we saw your innovations in seawater and also in brackish water. And so I don't know what any other type of water there is. So what's next from here, Boris?
I would like to add a little bit that in addition that we make in a big semiconductor company in Israel, this project has worked well. It is in Cherokee, works also well in the municipal wastewater. We are making 90% recovery without chlorination. And I would like to explain a little bit about no chlorination, because bacteria can live in any condition. In high salinity, middle salinity, low salinity, high pH, middle pH, low pH, high velocity, middle, whatever. They are able to live in any condition. They are not able to live in variable condition. If you have low osmotic pressure minute, later you have high osmotic pressure, lower osmotic pressure, high osmotic pressure, low velocity, high velocity. This, they are not able to withstand fast variable condition. So we are not having biofouling. We make many autopsies. There are no biofouling in municipal wastewater, and this allows us use to operate it without chloramine, without HDMA, without all this cancerogen what related to the chloramine. I would like to tell that in my best friend's Nadav plant in Maagan, we pick up his brine stream, what he has in his RO plant, something about 80% recovery. We pick up this brine and make additional 80% recovery on this stream. So we are reaching extremely high recovery. In Abilene, we make the same. We take a brine from existing commercial RO what operate 85, and we made additional, if I'm not wrong, something about 85 or almost 90% recovery. So
I know in Cherokee. I know in Cherokee what is the recovery. What is the recovery in Cherokee?
92%, 90 period we work 95%. Yeah. So it works well.
So it's really outstanding. And well, so you have provided another good tool to comply, to work, to fight all the scarcity problems in the world. So what do you have in mind now? What is next?
There are several projects. One I will explain right now, the later maybe a little bit later, but I work on the osmotic power generation long time. The idea is coming from absolutely great person, Sidney Labe. Sidney Labe developed the concept of the osmotic power generation. He was the person who developed the reverse osmosis membrane, but in addition, he developed the osmotic power generation. But there are a problem inside of this concentration polarization and so on, so it is not going so well. But I started to work on it about 20 years ago. I worked with StartCraft and we make a design. Later, we joined the Danish company, Salt Power, great company, great person. And we put little bit of our technology inside of their osmotic power generation plant. And it works. It works very, very well. The osmotic power is very suitable for Israel. It is very suitable for Israel because Israel has the Dead Sea, which is 26% TDS. It is almost 300 bar osmotic pressure. And Dead Sea lost every day million cubic meter a day of evaporation. So if we will combine the energy what there are in the Dead Sea with our ability to make desalination, we can make very interesting project. So when you are making desalinated water in Mediterranean, where you have 4% TDS, you should spend 3.5 kilowatt hour per cubic meter to produce 1 cubic meter of desalinated water. If you move it to the Kinneret, to the Tiverian Sea, fill up the Tiverian Sea and send it by Jordan River to the Dead Sea, in the contact place between desalinated water, what you invested 3.5 kilowatt hours, in osmotic pressure of 300 bar, you can reach almost 30 kilowatt hour per meter cube.
So
Water.
you send 1 cubic meter of desalinated water that where you invest 3.5 kilowatt hour for this, and you get almost 10 times more in energy.
About 7, yeah, about theoretically
Okay.
about 8 times more energy from the same cubic meter. But you solve also the issue of the lack of water. In addition, what you give this energy, lack of water, because when the desalinated water will reach the Dead Sea, it in the end will come to Dead Sea. It is no way. You cannot keep it. It is only give you energy and going to the sea. In sea, it will evaporate again. The salinity will not change. So you have form of perpetuum mobile, but operated by our sun. The energy of the sun practically provide us this opportunity to make desalination in the Mediterranean by 3.5, fill up all the bodies of water in the contact with the high osmotic pressure in the Dead Sea, you will get almost 30 kilowatt hours. It is terawatt of energy.
So you can do it with no carbon emissions to the atmosphere.
Absolutely. Right? Absolutely. It is absolutely green energy, very suitable not only for the Israel in Dead Sea, but very brilliant. It is brilliant project for Jordan together with Israel. It is brilliant project to make it with our neighbor. And I hope I will be part of this project. Right now, part of this project is in production. So the Western Galilee desalination plant is under construction.
And then
then Mikorot is already turning the pipeline from this Western Galilee into the Dead Sea. It is also in operation. What we have to do, we have to put pilot on the Dead Sea and bring the desalinated water with the contact with Dead Sea and demonstrate the osmotic power generation. And we have a partner, Salt Power, the Danish company, is ready to be together with us. We put small part of our technology inside of their technology, and together we can make it and demonstrate it and provide to Israel practically free energy, because you take small amount of energy for desalination and get big amount of energy from osmotic power generation.
This is great. And when do you think it can happen, and how it can happen?
The people have to turn their eyes to this story, understand it. I think it is lack of understanding right now, because I'm sure very little people know about it. And to make it known to the public, I think this is the main challenge right now.
Great. And I see that you have a sign of the Wikipedia on the left side of the slide. So what can people see there?
They can go to the Wikipedia and see what the osmotic power is. It is power generated when the two salinities are coming together. For instance, it can be seawater with wastewater, but the energy is relatively small. But if you take, for instance, the salt from salt domes, what the Salt Power has a patent on it, and put it together with wastewater, you will have a great energy. In salt lakes in the United States, they also have source of high osmotic solution, so they can make osmotic power in the area of Salt Lake. There are a lot of water coming inside of saltate.
And regarding the technology, you are using here special membranes?
We making right now membranes better suitable for osmotic power generation. We are in the process. I don't like to go deep inside of it, but we are making membrane what will be very good for osmotic power generation. And it will be great to invite the company Salt Power that already have commercial units of osmotic power generation. They already have them.
Great. So maybe we will invite them for a webinar.
Yeah, I very recommend it.
Okay. Okay. So it is really inspiring, all these innovations. And I think we could keep talking forever, more or less. So before we finalize this very, very nice conversation, you know, you are really inspiring a lot of people, and you are very special. And I would like you to help us have better and good innovators in the future. So can you just give some tips for the young people or the young generation to follow your way as innovator?
I will be glad to do it because I look very closely how the process is working. And I think that everyone who like to make innovation has to become little bit child. What does it mean to be child? When child see the, Leon, for instance, he don't know what to do with Leon, or to give Leon guli guli guli, or to give to Leon, sandwich, or run from the Leon. Don't know what to do, and he tries all these things. So the people in age, they know Leon, they have to run away. But kids don't know it, and they try all things. So I recommend to the people who would like to make innovation, forget of all the solutions that are standard, and like a child, look in very, very unusual ways, and make to Leon guli guli Leon.
Don't be afraid.
Yeah, don't be afraid. Yeah, I think this is the way.
Okay, Boris. So I think for me it was a great pleasure, and I hope all the people who joined this Israel Desalination Society webinar, I hope they are happy. So thank you so much for taking the time to speak with us. Your interview provided a fascinating view into the thought process of an innovator. And I want to tell you that it's clear that you are truly special individual. Your innovative abilities are fueled by remarkable range of skills, and you're not just a brilliant engineer, but an interdisciplinary expert with a deep understanding of all project aspects, from electromechanics, chemistry, membranes, to hydraulics, and even biology. Okay, you have a gift for discontracting problems, reconfiguring them into more efficient and effective solutions. I think it's not enough that you do guli guli. You have much more skills, and beyond your technical expertise, you possess a comprehensive vision on the project. You can see the big picture and the details at the same time. You don't just focus on the technology itself, you grasp the commercial needs of the project, and with the very detailed design them for efficiency, not only efficiency, but also profitability. Furthermore, you have remarkable foresight and you are always anticipating future market demands and proactively shaping your work accordingly. Finally, your charm and ability to connect with people allow for a rich exchange of knowledge and ideas. This fosters an environment of mutual learning and growth for everyone you collaborate with. Always smiling, guli, no matter the challenge you are going through. For all these reasons, I want to express my deepest gratitude, my deepest personal gratitude. Thank you for being my mentor throughout my career and for inspiring countless generations. You are a true role model for us all. Sorry that I wrote it, but I didn't want to miss any idea or feeling I have. Okay?
Thank you very much for inviting me. Thank you very much. Thank you.
So we have here a question. I don't know. Let me open the chat. People are saying there be an okay. One of the questions by Michelle Baruch: will there be any environmental impacts of this project on the Jordan, the Sea of Galilee, or the Dead Sea?
First of all, we will keep all these three water bodies, the Tiberia bodies, Jordan River, and Dead Sea, full with water. And we bring desalinated water without any salts. So it is water what will come and evaporate from Dead Sea. So we will keep the same salinity all the time. Million cubic meter will come to the Dead Sea and will be evaporated from the Dead Sea. And later we will, this is a perpetuum mobile kept by sun. So it was no negative, as I see it, no negative aspect on all environmental condition in Israel.
So maybe there is the opportunity to start searching the solution and searching the impacts, and maybe in case there is some impacts, mitigations steps can be taken.
Right.
Time.
Right.
So this is a very important, I agree with you, to start. Also, Michelle asked, you mentioned Larnaca, Ashkelon, Carlsbad, and then Sorek. But what about Hedera? This is where I met Boris at the WOTEC in 2007 or 2009. How did the Hedera plant help make the transition or development from Ashkelon to Sorek?
Practically, I was not involved deeply in the design of the Hedera plant in day-by-day design. There are other people. Miriam Feigon first was the leader in this design. But the design is very similar to Ashkelon. It is pressure center. It is 8 membrane. It is cascada system. It is post-treatment where you have limestone reactor with additional activity. So it is practically the same like Ashkelon, and I was not involved directly in this project.
But it is, let's say, another one in the series taking your innovation and also operating with an outstanding operation and improving efficiency day by day. So it was not mentioned because Boris was not totally involved there, but still is one of the flag projects. for Israel.
Right.
So Jackie Ron is asking, what will be the pre-treatment requirements for Jordan River water going into PRO?
You know, it is maybe will be like pulse flow RO 5 plus, SDI 5 plus.
The pre-treatment?
The pretreatment for osmotic power generation can be very similar to the pulse flow RO, because we will also have a flash by pulses.
Ah, wow. That's I didn't know.
Okay.
Okay, so I think we have answered at this stage on the many questions we had. So thank you very, very much, Boris. And I want to invite now our audience to join us in future webinars that we will have in the next months here at the IDS. Well, we are all here almost showing that we have a normal life, but it's not so easy. And I want to say that we are all praying for our hostages to come home as soon as possible, even now.
Absolutely.
So thank you very, very much to all who attended the meeting, the interview. Thank you very much to Mayan and to Semyon. That is in addition to operating the largest desalination plant, he's contributing a lot for this event to happen, and to other people, Gal Zohar and other people at the board of the IDS. So see you next time. Thank you very much.
Thank you. Thank you.
Thank you. Bye-bye.